Welcome back to the channel, everyone. For today, we will be discussing Pandas, a very popular software in Python written for the purpose of data analysis and manipulation. Now, Pandas stands for panel data, which means that it can analyze or it can help you manipulate the data sets or tables that are of numerical or cross-sectional format and of time series format. There's also one interesting reason why you should learn NumPy and Matplotlib before learning Pandas. It's because Pandas is built on top of these two core programming libraries of Python. And the wrapping is done in such a way that you can access the methods of both Matplotlib and NumPy with less code. The Pandas library doesn't come as pre-installed for Python, and so you have to install it in the normal way, either through pip or through conda. But assuming you have installed it already, then we can import Pandas, and the shorthand that we will use is pd. So the first lesson is how to create a data frame or a series. So this is how we create a data frame. It's pd.dataframe. And the normal variable for this is being used over the internet is df. Take note of the syntax. The data frame here has both the letter D and F as capital letters. Data frame. Okay. Now you can verify that the type of df is of course pandas.core.frame.dataframe, and that it doesn't have anything yet. In the same way, if you want to create a series, you can do so as well with, and let's say for example here, series pd.series. Now, what's the difference between a data frame and a series? Well, technically a series is just a one-dimensional array that can hold data of any type, either integers, floats, or strings. But a series, both a series and the data frame has an index, and of course it's data. A data frame is like a normal table, so it has both the rows and the column, and therefore a nice way to sum it up is that a series is just like one column of that table. There are many ways to create a data frame, and we'll first explore how to create a data frame through lists. So suppose, for example, you have the following lists: characters, shows, and the number of seasons they appeared in. And let's start to create that. Let's say, for example, now you want to create a table out of these lists. So the code will be frame from lists. Be as follows. So let's name this df from lists, and it'll be pd.dataframe. Take note of the capital D and F. And in this particular case, you'll have to turn them into a dictionary. So you'll utilize here both the list and dictionary. And the key of the dictionary would be the column title. So here's the character, and you'll supply as a value for this one the list that would fill up that column. So here would be the show. Okay, and we have here the shows, and have here the seasons they appeared in, and of course the seasons. Okay, and now if you call on the data frame list, you manage to create a data frame where you utilize a dictionary. The key of that dictionary becomes the column titles, and the list as the corresponding value for those particular keys become the rows associated with that column. You can also create a data frame by passing a list of dictionaries where each dictionary represents a row. So take note of this particular example. So one dictionary pertains to one of the shows. You have the character, the show, and the strength in this particular example. But take note that in order for this particular code to work, that the particular keys must be aligned, because the keys will be interpreted as the column names. So for example, so if we enter this one and create df out of that, it's as simple as pd.dataFrame, and here we pass it on data, and here we could, okay, so for this to work cleanly, each of your dictionary that will be part of this list must have the same keys, and only the values for the keys should change. Because, for example, if this is not present, for example, in this case, okay, we have one key that is not aligned, and we created something like this one, you would have an empty value for that particular column. If you've already created series and you want to turn them into a data frame, that can also be done through Python. So let's say, for example, we have 3 series, and in this particular case, we have character series, show series, and weapon series. Take note of the syntax. In creating a series, we usually have 2 arguments. So the first one is a list of what you want to turn into a series. So this can be strings, integers, float. So this is a list of names, and put in the name parameter or argument here. This would be the series name. So this name argument in this particular case would be what you call that series. If you then turn this into a data frame, that name will become the column name. So to do that, it will just be very simple. It will just be, so let's create that from the concatenate method. So it's pd.concat. So concatenate means we're really just putting them together, right? And the argument here would be always 2 things. One is the list of the objects or the variables that you want to concatenate, and in this case we want to concatenate the character series. So let's copy that, the show series, and the weapon series. Okay, after that we need to supply another argument here, which is the axis argument. Now, there's 2 possible answers for the axis argument. 0 for row-wise operation, meaning you want to flatten the series. So the character series, and then the show series, and then the weapon series. But axis equals to 1 makes it a column-wise operation, such that each of this series becomes now a column. So axis equals 1, column-wise operation. So we make it axis equals 1 and call on the newly created data frame. And okay, so we have to create this first. Okay, and after that we can now have it this way. Now, just an exercise, or just for us to see, if you're curious what would happen if you turn this into 0, which is the row-wise operation, then it will be flattened into one row, because after the character series you'll have the show series, because it becomes a row-wise operation. So just for you to see that, so you have it. So after the last character here, Rick Sanchez, you have the show you, and then after the Rick and Morty here, you have the weapons. So we don't want that. We want the column-wise operations, and we have 1 series. And finally, we can create a data frame from a list of tuples. So each tuples in this list represents a row in the data frame. And before you can input this particular rows, you have the option to specify the column name. So let's see that in action. So first let's create the data. So you have here data that is a list of tuples. And to create the data frame out of that, so pd.dataFrame with capital D and capital F, you know that already. And of course, you just input the data. You have this. So for example, the default column names will be the numbers. So Python starts always with 0, so 0, 1, and 2. But if you supply here column names in the column parameter, of course, you supply a list. So this one is for the characters, and this one is for the show, and I think here we have number of seasons, and of course I think this is already 5 there. So we can store that in a variable df.tuples. And as you can see, each of the tuple becomes the row, and it's necessary if you're going with this method to supply column names. But of course, I'll teach you another method, how you would name that if you didn't supply this one. But first, let's store this and call df.tuples. Now let's assume that you haven't supplied this name in this step of the code. Okay, so let's have that. So now you have 0, 1, and 2. So to rename that, you could just call on the df.column. So this method calls the columns of that particular data frame, and you can equate that with, let's say, character, season, and show, and season. So now if you call on df.tuples, you have assigned this list of string to be the column name, then you have that as the column name. Now we will learn how to load data sets into Pandas if you have them as flat files or local files. Now if you go to files.grouplens.org/datasets, you'll see a lot of data sets that we can use for this particular exercise. But as you can see, we could use here the movie lens. So you could just download here the ml latest small zip. Okay, so once you have that already, you could unpack that in a particular local folder, and we could try to load it into Pandas. Assuming that you've already unzipped the file that we have just downloaded, it's ideally placed within the working directory of your current Jupyter notebook. So in this case, this is our Jupyter notebook, and I've unzipped the data set here. To load that, and we know, for example, if you navigate here, we know that the files are CSVs. So what I'll do is I'll use the read CSV method. Okay, Pandas is very much capable of reading other file formats, JSON, Excel, and there are appropriate methods for that. But since this is a CSV file, then we will use the pd.read_CSV. And the first argument here would be the location, because the current working directory of our notebook is the base, right? I only need to supply this folder, ml latest small, has to be exactly the same, and I can get in here movies.csv. Okay, so that's a very important point. Where your current notebook is, that is the base from which you need to point Pandas to the file location. Okay, and let's store it in a file name called movies. Okay, and can view movies right now. So this would be the movie data frame. Before we go on and perform data manipulation in this particular data set, let's take this as an opportunity to study what other arguments or parameters we can use for the pd.read_CSV. So the very first or positional argument that we have is really the file path, and you've seen that. But sometimes you will have a text file that has, let's say, a separator. So you would use it, or a delimiter here. Header here is by default, the default argument is infer. So you'd seen earlier when we've run the movies, or we call the movies variable, the column names were assumed to be from the header provided. So if you want to, let's say, not use a particular column, you could use this argument. So there are a lot of things that you could use here to fine-tune the reading of your CSV. So let's say, for example, what I normally use is skip rows. There might be CSVs as well that are blank at the beginning. So skip rows would skip those rows. Or sometimes you have data set or that are very dirty at the bottom rows, so I use skip footer or something like that. So take some time to know the arguments here that can fine-tune your reading. But of course, if you have a very clean way, or if you've maintained your CSV in a very nice format, then this argument would most likely already provide a very nice output for you. Now we will go on to study the methods that we can use to inspect and manipulate our data frame. So the first is, after loading this particular data frame, movies, you could use the .head method to inspect the first 5 rows. Of course, if you want to inspect more than just the 5 rows, the default here is just the 5 rows, you could input as an argument here the number of rows that you'd like to examine. So for example 7, you will have the first 7 rows. Now, if you don't want the first 5 rows, you want the last 5 rows, then the syntax or the command there is movies.tail. By default, it will also give you the last 5 rows. Of course, if you want the last n rows, just supply n here as an argument in the movies.tail. So for example, the last 10 rows, and you'll see all of that. To examine the columns of your database, remember here that columns are your features. You use the .columns method. So here you would get movies columns. We have 3 columns: movie ID, title, and genres. If you want to have more information on your data set, you would use the .info method. So here, movies.info. And for the movies.info, what you'll get is, of course, the column index. This is the column index, right? This is the column title. And here, you'll get to see the number of non-null. Lastly as well, you'll see here the data type. So for the movie ID, you have here an integer. And for the title and genre, you have your object or strings. The range index here as well tells you what range they have used. So you have here 0 to 9741. You have 9742 entries. If the index is, let's say, of letters, you have it here, the letters. The .info method as well gives you the memory usage of this particular variable that you've stored. And of course, here the D types is the count of those particular types. This particular column has one series that is of int64, or one column that is of int64 type, and 2 columns that are of object type. Now, using the built-in len function on the movies or on the data frame variable, you'll get the number of observation, and we've basically seen that earlier, 9742 entries. However, recall that for our NumPy, we have the .shape, which tells you the row and the number of rows and the number of columns. So therefore, if you use that on the movies or the data frame of variable, use the .shape, then you will have in here a tuple where the first element of that tuple is the number of rows, and the second element pertains to the number of columns. It's time for us to learn how to subset or slice a data frame. When we want to slice a data frame, we can do so by just isolating columns, or just getting rows, or a combination of both the rows and the columns. So let's first do that with our movies dataset here, right? And let's just call on our movies data frame, right? So in this particular case, if I just want to get the title, the format would be this. So it's a square bracket and just getting the title. This is a series, okay, with just getting the title. If I would just want to get the genres, I could just get this. If I want to get the movie ID, then I can do this, right? Now, if you want to get just the rows, we would use the movies.lock, the .lock method. So here, the lock stands for like the location of that particular subset that you'd want to get. So for example, in this case, if I want to get the 0 to 15, then I have the 0 to 15 index, The index, by the way, it's very important, is found in this leftmost information. If you don't supply an index name, there is a method to supply an index name. It can be a DataFrame ID, unique ID, or just a string. Maybe the title can be the index. But if you don't supply an index name, by default, it would follow the range of values. Okay, so we are cutting it here. Now, let's say, for example, I want to get the 0 to 15 and the just the genres, for example. So if I just want the genres, then I can do this. The .lock method can have two arguments that are separated rather by a comma. So in the left of the comma is the row subset, and on the right of the comma is the column subsets. So for example, in this case, if it's just genres, then you're able to do this. But let's say, for example, you want to get both the genres and the titles, and you want to leave out the movie ID. So this is how you do it. So you have it here, the left of the comma, the row identifiers or the indices that you want to slice or subset, and at the right of the comma is a list of the column names that you'd want to get. Now, if you don't have the index that you're going to slice, you could use the ilock method. Ilock here stands for integer location. So for example, here you want 0 to, let's say, or maybe just negative 500, last 500 to the last observation. And here you cannot supply the column names anymore, because integer location means integer location of the column that you want. So let's say, for example, the movie ID and the title would just be 0 and 1. So in this case, it will be this. Okay, so this is the last 500 up to the last value. Okay, so if you first remove that, increase 1 here, 9741, and this, again, the same format. You, after the comma here, you supply the column identifier, but in this case, instead of the name, because you're using the ilock method, you're supplying the integer location of the columns that you want to get. Of course, if you just want 1 and 2, then that changes the subset that you got. Interestingly enough, using the .lock method, you can actually, once you subset, you can actually exchange their position. So for example, if you want genres to go first, then just exchange that position this way. Just like you telling Pandas that you want your subset to just contain the number 0 to 15, and the columns in these positions are genres and, let's say, for example, title, and you're able to exchange the location of the particular columns. You can try that one again here. So for example, for the movies, if you want movie ID to be last, then I could just do this. Out of subsetting it, I could input a list where the position of the column names will be rearranged according to how I want it. So let's say, for example, titles, and then genres, and then lastly would be the movie ID. So okay, so this here, titles, not index, maybe just title there. So the movie ID is now at the last, and of course I could save this in a new array, or sorry, not new data frame, rearrange df. There. Before we begin with the subsetting or slicing of the data frame, it's very important for us to understand what the index is. It's not the same as the column. Instead, the index is the label or the identifier attached to each row, and it sits at the leftmost portion of the data frame. Take note, this is not a column, And if you call on the DataFrame.columns method, you won't be able to see the index. But this index allows you to access, modify, and manipulate rows in the data frame efficiently. Some of the key characteristics of the index is that it's always found on the leftmost part of the data frame, but is not considered a column. And the default behavior is that when you create a data frame, Pandas would automatically assign a default index that starts with 0, of course, just like Python's standard indexing. The index is important because it allows us to perform a lot of tasks that would be impossible or very difficult to do if we can't identify the rows. So some of these tasks includes locating the data. When we want to access or modify specific rows, we typically use the index. Another is aligning the data. During operations like merging or concatenating data frames, Panda uses index to align data. Last but not the least is reshaping data. Functions like groupby, pivot, and stack use the index to reformat the data frame. In Pandas, an index serves as an identifier for the rows of the data frame. So just as the column names help to identify the columns, the index serves to identify the rows, and it will help tremendously with the task of data retrieval and manipulation. So if you don't have an index that you have in mind, when you load the data frame, Python would by default assign its integer-based system where the first observation will be 0. So to identify the current index that is being used by your data frame, you would use the .index method on the data frame variable. So here you could verify that it uses Python's index-based system that starts with 0. Now, if we want to change this to say something more meaningful or something that we could easily remember, for example, because it may be very difficult for us to remember the which observations lie at which integer location, right? So we could assign a column. So in this case, if we look at our movies, we can assign, for example, movie ID to be the index. To do that, we use the setIndex method and the column name here, movie ID. Now, another variable that we need, or another argument that we need to input here, is that of the inPlace method. InPlace means that Python will change the original variable, which is the movies here, in place, so we don't need to assign it. Otherwise, look at what will happen. By default, in place is false. If you've done this particular code, we set the index to movie ID and you call on movies again, you'd notice that we didn't really change the index. And as you might recall, the index is always the leftmost part of the data frame. And in this case, it's still the integer based because in place here is set to false. So if you set this to true, meaning that the code will now work by changing this variable that is in memory or in place of memory, then now the leftmost part of the data frame or the index have been successfully changed to movie ID. Say, for example, now that you want to undo this, then the same can be done, and it's the reset index. Okay. At another argument here, you still would need to place the in place true, because now if you call on movies, it still hasn't changed because we haven't supplied this argument. Okay, so in place equals true would now reset this particular action or the index that we have. Resetting an index would mean that it will now become part of your column. Okay, that's what happens when you apply the .reset index method. It will now be part of the column. Now you have the option, so in this case, reset index, to either drop it. So let's say here, you have the option to either drop it or retain it. If you don't drop it, for example here, drop equals false, then this particular integer base index will become a column. So let's see that in action. Now if I call on the movies, because as you know, reset index turns the index into a column again, just like what we've done. Then you see here that we have here a column that is index. So let's see what would happen if we supply true in the drop argument instead of false. But let's first drop this index column. You can verify that it's now become part of the columns, and you'll see that index is there, and we want to drop it. So it's gonna be movies.drop, and we want to drop the index, and index is axis 1 means that it's a column that we want, and therefore it's no longer there. But please don't forget to supply the in place true for this type of method. And now movies would no longer have that index. So let's try the reset index, supply true, and then in place true. And there you'll see that we don't have an index column like we had earlier because we have chosen to drop that particular index. Now let's try again to set the index to, let's say, the title. Okay, so we're gonna reset it anyway, but just so we know how we could use the new index in the .lock method that we have just learned. Okay, so if you've chosen the title to be the new index, so now the leftmost part is the title. Now if I want to, for example, get this particular column, then what I'll do is, now it's no longer using the integer base, so I can't use the numbers. What I'll use is this particular name. So I'll copy this and this one. So we're telling Python to locate this particular observation, and there you see it. Continue. Please remember to reset the index and turn it back to the original movies data frame that we've had earlier. Now for the next part, we will be using the ratings data frame by using the ratings.csv. So it should be on the same folder as that of the movies. So after running this, you'll have the ratings, and you could inspect it with ratings.head. Okay. Now let's say, for example, that you have here a rating of 1 to 5, and you want to create a column here which is called the rating description that maps out this rating into a textual description. So let's say, for example, 1 is worst, 2 is bad, 3 is satisfactory, 4 is good, and 5 is excellent. So in this case, we want to initialize an empty column first. So to do that, you would put the new column name. So let's say here it's gonna be the ratings description in a square bracket and the square bracket contains the new column title. And to initialize it, you can either set it to, let's say, 0 or 1 or none, but it would set all of the entries of that column into this one particular instance. So for example, in this case, if you now call again the ratings description has been initialized, meaning there's now a column called ratings description, whereas earlier it didn't have that. Okay, and that because it's been initialized to none, all of the rows under that ratings description has the value of none. Now we can proceed to change this using the for loop, so we'll try that one now. So we could for index in range length of ratings, okay, if ratings dot lock, and because it's still using the integer base right now, we could use the index here, the number, okay, index, and you want to check this one, rating, if the rating is equal to 1.0, then what you want to say is change ratings. Of course, you want to change that particular one, the index that matches that index, and just copy this one. Instead of the rating, you want to change the description to be equal to worst. Then proceed to elif ratings equals to 2. Then the ratings lock rating description would be bad. Okay. And we can copy this for a few more times. Three. This would be satisfactory. And then here, okay. Okay. So it would be good. And finally, we don't need an elif there, it's just else. And then this ratings, the rating description for that particular index would just be, okay, excellent. Okay, so it's going all through that range. Okay, and let's wait after it's done. Okay, so it actually ran a bit longer than it should because the for loop is not that efficient. It's actually going through each of the rows. So now let's check our ratings data frame. Okay, so there, if you could see there's, I don't know why we have two ratings description here. I must have initialized this twice, but you could see there that we were able to change the ratings description. But I'll teach you how to do this in a much more efficient way. So for that to happen, let's reload the ratings. So that reloading it would remove the ratings description that we have done, and run this again. So now we have the ratings description, but we have undone the progress that we have done earlier here with the for loop. So it's basically using the .replace method. Okay, so the .replace method is very similar to how the replace function works in Excel. Alright, so to make it more efficient for this type of replacement, what we could do is create a replacement dictionary. So for example here, replace dictionary, and in this case we can say that the keys would be 1, so that would be first, and then 2 would be bad, 3 would be satisfactory, 4 would be good, 5 would be excellent. Now that we have this, actually use it here in the rating column. So we're basically just calling this one, and then .replace, and the argument for the replace method would just be the replacement dictionary that we have created. It will understand that you want to replace the value of the keys with the one on the columns. So we're not assigning it, but you'll see that, for example here, you were able to change it, right? Good, 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 excellent, and it was so efficient. Now if you just want to assign all of this to the ratings description column, so here ratings, and okay, now when you call on the ratings data frame, you'd be able to, okay, so sorry, we have, it's supposed to be ratings description, so we basically just created a new column called description, so and assign that value. So there, and there you have it. So now we can exercise our dropping. So let's drop the description, place 2, and axis equals to 1. Okay, and there we have it. Now, one more example for the dot replace, but let's do it for the movies. But let's say, for example, you just want to change a portion of a column and not entirely the whole column. So let's say, for example, here you want to change all of the animation to animated. So maybe we could just apply movie.replace, and then here animation, replace animation with animated. We could review here the arguments for the dot replace. Okay, so we have here the to replace and then the value. So this is that. So to replace animation, and the value that will replace it is of course animated, and you want to have that change in place. But if I run this, the animation won't still be replaced with animated because we still need to supply one argument. So if you run it and then look at movies, okay, you'll see here that animation is still not changed to animated. That's because the to replace value looks for the exact text. So in this case, it's not treated as an exact text because there is other portions of it like comedy, fantasy. So the only way that this will be changed to animated is if I supply this one. So for example, just for trial, so let's say for example I have this, and then therefore here I would change this to animated. Okay, then in this case, if I call on the movies, then that particular instance has been changed. So this method would only work if you knew exactly the pattern or the exact string that you wanted to change. But what if you don't know the exact pattern that you wanted to change? So for example, for animation, like this one, it's not the same as this row, but you want to change this animation. You want to change all animation to animated. Then in that case, you need to supply regex equals to. So it's another package, but regex here, or regular expression here, means that it will look for partial matches. So now if we supply this argument and enter it here, all of the animations, so even this one which didn't match, would now be turned into animated. Now let's find out how you could apply a function into an entire column. So you could use the for loop again, but there is a simple way to do it, and that is the .apply method. So using the ratings again, suppose for example you want the rating to be turned into percentage, where you need this to be in terms of 1 is 20%, 4 is 80%, and 5 is 100%. So what we need to do first is to create a function, and maybe we call that function rating to percentage. Okay, and here we have the rating, and get the rating over 5 and multiply it by 100. So this function is what we will be supplying to the .apply method. So to do that, we have here the ratings, and you want to apply it with the rating. So this is the number. If you use the .apply method, the argument here is that of the function that will be applied on a per row basis. And the function that is being applied here will take the object of each column as the input to that function. So if you look at that, it would automatically apply it here, and of course we can create another column, and you can basically simultaneously instantiate a new column and assign this value using this method. Call this the ratings, and calling on the ratings DataFrame, and you have both the ratings description and the ratings percentage. Using the dtype method earlier, we were able to understand the data types that is found in a data frame. So for example here, the dtypes, you saw that for rating, it's a float 64, and for the movie ID, it's in 64, and the user ID is in 64. Now, let's say, for example, you wanted to change the data type of this particular column. You could do that by the astype method. So, for example, here, for the rating, it doesn't make sense that it's float right now because if all we've seen is 1, 2, 3, 4, 5, it's just 1 out of 5 and nobody's assigning a decimal value. So if you want to change it to int or force it into an int type, then what you would do is have that rating, and then here dot astype and supply it with int. Of course, we would reassign that so that the change would be cascaded to the data frame. Okay, sorry, ratings. And now, if we call on this again, ratings.dtype, you see that we were able to change the ratings data type. We could then check by calling on the ratings data frame, and the rating column has now been changed into integer data type, and you no longer see decimal places in the values. Now let's talk about how we can merge two data frames. The merge function in Pandas allows you to combine two data frames based on a common column. Let's say we have two data frames. Movies data frame contains both the movie ID and the title, and the ratings data frame, which contains the movie ID and the ratings column. So here, let's look at how the four types of merges, inner, outer, left, and right, would work. Let's first discuss the inner join. So what it does, it keeps only the rows where movie ID, which is the column that we want to merge on, exists in both data frames. Only the movies that exist in both data frames with movie ID 1 and 2 are kept. So movies like Interstellar and The Dark Knight don't have ratings, and movie ID 5 in the ratings data frame has no corresponding movie, so they're excluded. The key here is that the movie ID value, or the common column that you're trying to merge on, should be found on both data frames. Now let's discuss outer join. What it does is it keeps all rows from both data frames. If a movie ID has no match, missing values, none, NaN, are filled in. All rows from both data frames are included. Interstellar and The Dark Knight with movie ID 3 and 4 have no ratings, so the rating is NaN in that column. The rating for movie ID 5 has no corresponding movie, so the title is NaN. Now let's discuss left join. What it does is it keeps all rows from the movies data frame, which is the left data frame, and matches ratings where possible. Missing ratings are shown as NaN. All movies are kept because it's the movie data frame that is being prioritized. Maybe it's easier to remember, for the left join, the left data frame is preserved. So Interstellar and The Dark Knight have no ratings, so their rating is NaN. However, movie ID 5 from the ratings data frame is excluded because there is no corresponding movie that matches it from the left data frame. And finally, let's discuss the right join. What it does is that it keeps all rows from the ratings data frame, which is the right data frame, and matches movies where possible. Missing movie details are shown as NaN. So in this case, because the right data frame is the ratings, all ratings are kept. The rating for movie ID 5 has no corresponding movies, so the title is NaN. However, Interstellar and The Dark Knight, movies with movie ID 3 and 4, are excluded because they have no ratings. So let's apply what we've learned through coding. So to merge to data frame, we use pd.merge, And you could see here that the arguments that we would be needing is the left, the right, and then the how. We also would have here the on, which would be the common column that we want to merge on. Then the left would be the movies, the right would be the ratings. How? Let's try first the inner. And we wanted to merge on the movie ID. We can verify that both the movies and the ratings data frame have this column, and therefore we could supply it as the column where they would be merged on, right? So now here we were able to merge it, and you have here 100,836 rows. So we can now check if we use the outer. This would have the largest possible number of rows, so it's 100,854. Now for the left, we prioritize just the movies data frame, so you have 100,854, and the right as well would have much smaller, I think, so 836. That's why the inner would get the smaller number and the outer gets the larger number. So let's try first with the inner one and save it in a variable called merged df. Okay. Now it's time to discuss another similar method but has a different purpose, and it's the concat method. So you use the concat method if you want to stack data frames either vertically or using the argument axis equals 0, or by rows, or horizontally, or by columns, again using the argument axis equals 1. This is ideal if you want to concatenate or stick together data frames either by adding more rows with the same structure or adding more columns. So to compare the merge method with the concat method, for the merge method, you would typically require a common column or a key. Of course, you can always merge using the index, but the point is it needs to be present in both data frames. For pd.concat method, you don't need a common column, it just stacks or appends the data. Now, the typical use case for the merge is when you need to combine data frame with related data. So what we've been doing is that we are combining two data frame, one for the movies and the ratings, and they are related. But for the concat, it's really just for stacking row-wise or column-wise data. And finally, for access control, the merge method works row-wise based on matching values, while the concat method can stack row-wise or column-wise. So to see the concat method in action, let's first create this January and Feb sales and view them. So you have the January sales and the Feb sales. Notice that the structure is the same, but we really just need to append them or to concat them to one another in order for us to create a consolidated data frame. Maybe we want to call it, for example, running Q1 sales. And to do that, it's really just pd.concat. And as you can see here, the argument is a list of the data frames that you need to concat. Of course, the first argument will be the one that is on top of the concatenated data frame. So we want the Jan sales and then the Feb sales. And in this case, you want to stack it by row, right? So that would be axis equals 0. And we can view that now. So the Q1 sales, therefore, would look like this one. It's really just January, and then below it is a February sale. You really just appended two or stacked the two data frames together. Now, if you want to let's say append it on axis by equals 1, and you want to look at what will happen if you appended it by column, what will happen is that you have product ID sales month, product ID sales month, because you really just combine them. So again, the concat method would be quite helpful if you have data frames that you want to stack together. For example, this is a very strong use case, monthly sales that you want to combined, and you're keeping them in different data frames. So there. And now that we have this, we could perform some basic exploratory data analysis or descriptive analytics. So for example, here we want the merge df.describe, where the .describe would give us the descriptive stat information, but for the rating, you have here that the mean rating is 3.35, the minimum rating of course is 0, the median rating is 3 for the 50%, and the max rating is 5. So we kind of know this already, and the ratings percentage as well would follow this one, so no surprise there. But if you want to analyze the categorical information, you would use the .describe method with the include, and then here supply the O, and that is O for ordinal. So you have here the genre. So the top title is Forrest Gump, and it appeared 329 in your data frame, in the merge data frame. The top genre is comedy, and it appeared 7,196. The .describe method pretty much provides us with a very good descriptive stat, but if you want to do it individually on a column, here's how you would do it. So for example, for the ratings, you could simply just, okay, so you have that, so you could just apply the dot mean, okay, or it would be the same here with the mean value, right? Or maybe you'd like the maximum value, the minimum value as well, and maybe the median. So for the categorical value, description, maybe you could use the there. In Pandas, the group by function is incredibly useful for performing aggregation or summary statistics based on specific categories or keys. So using our merge df, let's see how this works. So first, let's say for example, from our merge df, we want to create an average ratings. So we want to group by, of course, it would be in the merge df dot group by that we want the ratings of the individual person to be grouped for that different movie ID. And let's say we have ratings, and then that mean dot reset index. So let's explain this code in a bit. And here we want to view the average ratings. If you've looked at the ratings, different users would rate differently for the same ID. So for example, for movie ID 1, you'll find that there are a lot of people that rated that, and we want to get the rating per movie. So this is a bit different from the one that we've had earlier, where the summary statistics is for the entire column. Here, you have the ability to group it according to a specific column, and in this case, the movie ID, and we want to get the rating, and we want the mean rating per movie ID, and here's how we got it. Of course, we reset the index, because if we don't do that, so for example here, let's try that. If you don't do that, then you'll have something like this one. So resetting the index would make the movie ID to become a column, and you've seen that earlier. So resetting the index is something that we normally just add, and there, so it becomes a data frame. Now, if you want to also, let's say, count and view how many people or users rated a particular movie, so you can use not the mean, but you can use maybe the count. And here you see that for movie ID 1, there are 215 raters. That's why it's very important to get the mean of that. For movie ID 2, you got 110 raters. And for some movies like 193581, you have 1 rater. Notice that this is kind of like arranged already or automatically, but it shouldn't, it's just a coincidence, because it's usually arranged according to this, the movie ID, and because the movie ID is arranged according to the len, or according to range from 1 to 193609, that's why we probably have this. So aside from count, for example, I want to determine what is the maximum rating given by the raters of movie ID 1. I could use max So of course, it will be 5 because there's 1 to 5. But for certain movies, well, we note that there's only one rater for this movie. Of course, the mean, the minimum, and then the max would be the same. Now, if you want also to get the mean, you can get that, or even the median, you can likewise get that. So if you want to have multiple aggregations, so for example here, I use the mean, but I want to see both the count and the mean. Certain executives want to see that. For example, yes, that's the mean, but I want to know how many rated that. So we could group by with multiple aggregation. So here, what we could do is merge df.groupby, and we're still going to group by movie ID, right? Movie ID using the column rating, okay? But we want to have multiple aggregates, so we can supply here both the count and the mean. So to see that in action, you'll have this, of course, and resetting the index would turn this index into a column again, right? So this is what you have. So for the movie ID, you have both the count and the mean. So as you could see in this particular case, group by allows you to aggregate data by a specific column, in this case movie ID, to perform calculations. And it's very powerful because you can it gives you more control over granularity of your data. As a last lesson for this comprehensive course, we may want to sort the information that we have. So for example, if you want to sort on the rating here, what we could do is call on sort values method, and we want to sort on, let's say, according to the rating, and we want it to be on descending order. So that would be ascending false, and you'll get here the top rated movies. Okay, so if you want it to be alphabetical and you want letter A to go first, so it's true, and then you have here the title. Okay, so of course you'll be getting the numbers or the punctuation first, and you'll get the last information to be those that have well, not really standard alphabet. So there you have it. So these are all the basic methods that you need to learn in Pandas in order for you to perform basic data analysis, basic data manipulation, and maybe even do some feature engineering. So hopefully this has been all helpful, and I'll see you all in more advanced Pandas lesson. Thank you.